Here's a really important skill, adding and subtracting polynomials. We really started with that, but today, like we were simplifying polynomials in the last lesson, and then today's lesson is simplifying longer polynomials, and they have to have brackets. And so when you have brackets, you have some different rules to follow. Okay? When adding's not too bad. Adding's pretty easy. Okay? Add the following. You're going to get rid of the bracket, and then you collect like terms. And that's really the same whether you're adding or subtracting. There is a little bit of a trick with subtracting. And the thing with adding is you actually just can remove the brackets. There's no trick. You know, the brackets are quite, in this case, if you look at it, there's no reason for the brackets. That's sort of redundant. So all you got to do is get rid of the bracket and add them up. And then it becomes exactly like we did. So this line here, I wrote the exact same thing with no brackets. Easy, right? And then I grouped. Okay, so I put all my x terms together and all my just number terms together. And 2 plus 3 is 5, and 9 plus 2 is 11, and that's it. Okay? What if you have a negative term? Well, it doesn't change. It actually doesn't change really anything. Same thing, just get rid of the bracket. Just remember, like I told you yesterday or in the last lesson, that this negative belongs to this 9. Okay? This negative belongs to that 2. Oh, and as I say that, I realize I made a mistake here. Hold on, hope you're not copying me. Because that's got to be negative 2. Okay? So 2x, so the sign stays the same, plus 3x, right? The positive follows the 3, minus 9, minus 2. Which means I made a mistake here. Hope you're not following along too fast, or writing too fast. Okay. Sorry about that. So got rid of the brackets, grouped, keeping the same sign with the number that comes after it, and collect the like terms. 2 plus 3 is 5. Negative 9, negative 2, everything is more negative, so negative 11. Okay? And I guess I just made this note here. If you see the term simplify, it just means get to the minimum number of terms you can. Okay, so obviously the negative caused some trouble, made me make a mistake, but really, it doesn't really change much. As long as you remember to keep, that negative belongs to the 9. That one belongs to the 2. All right. Yeah, here I have a negative with this 3x, okay? So, and I'm adding, right? So again, I can just get rid of the brackets. Just have to remember one little thing, which is that 2x minus 9, that stays the same. Nothing's changed there. I just got rid of the brackets. Remember that, like, I'm adding negative 3x, right? So that's just negative 3x. So you can just forget that plus sign right there and just put the negative. Okay, because plus negative 3 is the same as negative 3. And then that's negative. Again, collect 2x minus 3x and negative 9, negative 2. So 2 minus 3 is minus 1, and minus 9 minus 2 is minus 11. Okay? All right. Gets a bit complicated. You might want to take a little stretch here. It gets a bit complicated with subtracting polynomials. It's not awful, but it's just, again, I want to sort of cover this up. I don't want you to get distracted by the example, okay? I'm going to cover that up. Don't look at it. Don't look at it. I'm going to fill it up. I already have it written already. Okay. Like anything else in math you've done, when you're subtracting a polynomial, you just add the opposite of the original. So what does that mean? Well, opposite just means the opposite sign. So if you're subtracting 4x minus 2, really, like, the opposite is just minus 4x and plus 2, right? So first understanding why that. Now, let's just look at numbers for a sec. Well, subtracting an integer, if you have 5 minus 3, it's kind of like adding the opposite. Or I say the opposite is the opposite sign. So that's 5 minus positive 3, right? Well, it's the same as saying 5 plus negative 3. And that's really what we do with polynomials. When you subtract polynomials, you add the opposite. So you have to identify, like in this case, I'll get rid of that now. In this case, I'm subtracting 4x plus 2. Well, that's kind of the same as adding negative 4x minus 2. This is correct. This one's weird. So subtracting this is the same as adding, as long as you change the sign. And notice I changed the sign of this and this. You have to change the sign of both. Okay? So the opposite of 4x plus 2 is negative 4x minus 2. So once you do that, then you follow the rules we did above. So then you've made this the opposite. You turned this, right? You turn this into a plus, and you turn this into its opposite, right? And you turn that into its opposite, and then you just do what we did last. You get rid of the brackets and you collect the like terms. So now I did this, then I get rid of the brackets, 8x, get rid of these brackets. Remember, plus and minus is just minus. Same here, plus and minus is just a minus. And then I didn't do the grouping stage here, and you don't have to show me the grouping stage on your tests either if you understand, right? All I did to get 4x here was 8x minus 4x. Remember that minus 4 goes with, the minus goes with this. And then I have plus 6 minus 2, which is plus 4. Okay? Try another example. 3x minus 5 minus 2x minus 6. Well, remember the opposite of 2x minus 6 is negative, so I change the sign of this, change the sign of each. Okay? Both signs change. This plus becomes a negative here, and this minus becomes a positive. Both of them. Okay? So now, instead of subtracting this bit, I'm going to add this bit. Again, get rid of the brackets. So the 3x minus 5 stays the same. Plus a minus becomes a minus. Now this is now a plus, so it just stays a plus. Right? Plus a plus is plus. Plus a plus is plus. And here I did the grouping stage. See why you have to be good at adding integers, by the way? So you know 3 minus 2 is 1x. That's easy. Minus 5 plus 6 is plus 1. And let's do this one. Ooh, a bigger one. Oh, and this one's bigger. It's bigger and it has exponents. But that doesn't really change. It doesn't really change anything. So this is a minus. So I have to add the opposite, right? So the opposite of this, the fact that there's an x squared doesn't change the question at all. It just means that this, you have more terms to deal with. So this has to get changed. This has to get changed. Let's just highlight it, right? This becomes negative, sorry. This negative becomes positive for the opposite, and that negative becomes positive. Okay, they all change signs. Now I add them. And really adding them, you get rid of the brackets, you get rid of the plus sign. Right? Drop the brackets, drop that plus sign, and it's all the same. And then you collect the terms, right? 4x squared, you take the negative with the 3. This goes here. The plus 2x here, plus 5x here. Plus 9 here, and I'm not going to crisscross, but that plus with that plus. Then you do 4 minus 3 is 1x squared, 2 plus 5 is 7, and 1 plus 9 is 10. Looks harder, but really it's not really, right? Same thing. Sorry about that. And any more? Ooh, word problem. Okay. So, I'll let you figure out who Eddie, Mike, Jeff, Stone, and Matt are the lead singers of I don't know what band. So based on the work they put into the t-shirts, they will earn a different amount of money for the t-shirts as opposed to splitting the profits equally. So Eddie, they're selling t-shirts, okay? No matter what, he's making $5, but he also earns 0.2, which is 20 cents. $0.2, so 20 cents times the number of t-shirts that get sold. So this is no matter what, and then this depends on the number of t-shirts sold. With Mike, he gets $2.50 a t-shirt plus 10 cents a t-shirt. Plus $2.50 no matter what, sorry, plus 10 cents for every t-shirt. Right? Jeff gets a buck, period. Here's lucky guy. He earns $1. Stone doesn't get any money up front, but he gets 40 cents for every t-shirt, and Matt gets 30 cents for every t-shirt. So it says write an expression for each guy in the band for how much money they will earn based on a certain number of t-shirts sold, so no matter how much. So each guy. So Eddie gets $5 no matter what, plus 0.2 times the number of t-shirts. So that's pretty straightforward. I'm just reading it straight off here, right? This plus this. So Mike is going to be this plus this. Jeff is this plus 0. Stone is this plus the 0.4n, and Matt. Okay? Write an expression for the total amount of money earned for all members together. So that just means add all this up. Okay, so this is individual, right? What if we add them all up for the total amount of profits, the total amount of money made based on t-shirt selling? So the total is going to be, there's Eddie, right? Eddie. There's Mike. There's Jeff and his $1, lucky guy. Here's Stone and his 40 cents. And there's Matt and his 30 cents. Okay, for each t-shirt. That's what the N represents, the number of t-shirts sold. And then I'm going to simplify that. And I wrote it in the right order. So you have to put the N's first and the numbers last, right? So why is it just N? Well, 0.2 plus 0.1 is 0.3. 0.3 plus 0.4, 0.7 plus 0.3 is 1. So 1N plus 8.5. So that's 5 plus 2.5 is 7.5 plus Jeff and his $1. So that's why the 8.5. So all I did was add all the just numbers, right? And add all the terms that had N's. And lastly, we're going to use grass because it says determine how much is earned by all the guys together if they sell 100 t-shirts. So what's the earnings if they sell 100? Well, given N is 100, what's the earnings? The earnings is N plus 8.5. So all together they'll earn $108.50 if they sell 100 t-shirts, which doesn't sound like that much of a deal. They're not very, these are musicians, right? They're not businessmen. All right. Here's a weird word problem, and looking ahead to your final exam, they love these type of questions, so you've got to get your head around it, at least if not today, at least by the time you write your exam. But they're saying, say you have a rectangle, okay, so here's our rectangle, and we're going to say the width is W, so I'm going to just write a W right away for width, okay? And it says the length is always 2 times the width, plus 3. Well, what that means, and this is I wrote a little algebraic expression that this here, the length, is 2 times the width plus 3. Okay, so that might be the hardest part of the whole question, is taking this information and putting it onto here. It says write an expression for the width. Well, I said width is W. Write an expression for the length. Well, the length is 2 times width plus 3. Again, to me, this is the hardest bit. And so if you have a question, start and ask me about it tomorrow. Then it says write an expression for the perimeter. There's a question on, I've seen a question on the equal is like find an expression for the area. Could be that too, but we haven't learned that yet. So for the perimeter, then it's you just add up the 4 sides, right? That's perimeter. So it's width, right? So width plus 2 times the width plus 3 plus width plus 2 times the width plus 3, right? Because it's width plus length plus width plus length. Then you collect the like terms. If you're going to write an expression, you should always have it in like terms. So there's how many W's? There's 1, 2, 3, 4, 5, 6 W's. And there's numbers by themselves, just 6. Notice I wrote the W term first because that's the proper communication. So an expression for the perimeter is 6W plus 6. This is a hard question, but it's something you'll get some chance to practice it, and it's something you'll have to get your head around over at least the course this semester. So any questions you have, make note if you want me to help you with anything, and that's it for today.